GitHub, Reddit, Hacker News. Someone even bought a domain to track the phrase, "You're absolutely right." How did this happen to one of the most sophisticated AI companies of our time? We have some ideas. You can think of evaluation as a ladder. At the bottom you have S, a cheap proxy. An LLM-Judge, or heuristic, you can run at scale for fractions of a cent. In the middle you have Y, an oracle label. Human experts are expensive labels that cost real money. At the top is Y star, real user welfare. We usually can't measure Y star directly, so we aim at Y and calibrate S to predict it. Claude was rewarded by an S that ranked flattering outputs first. But for the actual target users, in this case software engineers that just wanted to get shit done efficiently, the ranking inverted. We call this preference inversion. Here are 3 ways this type of preference inversion might come about. The first is that they chose an S but never grounded it in a high-quality Y. The second is stale calibration. For example, people got tired of a certain behavior. Conditions changed since the last time they grounded an S and Y. The third is that the evaluation sample wasn't representative of the population they cared about. They oversampled certain tasks or users and failed to represent the target distribution. The fix is calibration. Here's how it works. Score everything with your inexpensive and abundant S. Label a small slice with Y. Fit a monotone mapping between S and Y on that slice, then apply the mapping to everywhere you have an S. Cheap scores become calibrated estimates. Here's some intuition for why this works so well. S is precise but biased. Tons of tight, wrong measurements. Y is unbiased, but it's sparse. It's expensive, so we don't have many, but it's much closer to representing what we actually care about than S. Calibration uses Y to debias S, giving you many samples anchored to the truth. Robust evaluation requires constant iteration and monitoring. We recommend tracking residuals over time. If they drift outside your band, becoming systematically different from 0, something changed. Recalibrate and consider collecting more Y labels. Another thing to watch out for is whether you can reliably learn the mapping from S to Y from one policy and apply it to another. In this context, you can think of a policy as representing a unique AI system configuration. So for example, prompts, model, retrieval pipeline, whose performance you want to evaluate. We diagnose this in the same way we did in the last scene for transportability across time. We check that the residuals are centered around 0. If they're not, we can't trust the mapping. Residuals are also a powerful debugger. Large negative residuals mean the cheap proxy loved it, but the end users hated it. The "you're absolutely right" meme is a negative residual that got shipped to production before anyone realized it was destroying user value. Inspect your residuals and fix what's being optimized or risk being ridiculed. The recipe is simple. We call it Causal Judge Evaluation, or cje for short. Pick an S and Y based on the trade-offs you face in your domain. Label a small oracle slice. Calibrate. Monitor residuals. Cheap evals you can trust. If you want the Python tooling, it's MIT licensed, open source, and pip installable. Check out the extensive documentation and write-ups at cmolabs.com.